this is Jo from Maths Tutor Me. Today we are looking at circles and cylinders, and we're going to learn how to calculate the volume of a cylinder. Now you may remember from a few topics ago that we learned about the volume of prisms. Now the formula for the volume of a prism is V is equal to AH, where A is the area of the shape at the front of the prism. Now this formula that we have here for the volume of a cylinder is actually just the same formula, except that the pi r squared is the area. Because a cylinder, the end is a circle, so this is the A, pi r squared, times by the height. Okay, so that's just a bit of an explanation as to where that formula comes from. So here it is, volume is equal to pi r squared h, where r is the radius of the cylinder and h is the height. We're also going to be converting between units of volume, like centimetres cubed, and we're going to be converting that into millilitres. So we need this little conversion here today as well. So let's do some calculations. We want to find the volume of the following cylinders correct to one decimal place. So let's write our formula down to help us learn it. V is equal to pi r squared h. Now, my radius is 7.1 and the height is 8.6. So let's substitute that in. Pi times 7.1 squared times by 8.6. And then all we have to do is calculate. Pi times 7.1 squared times 8.6. To one decimal place, we have 1,360, but all this is going to round up to be 2.0. Now we're doing volume, so this will be meters cubed, cubic units when we're doing volume. Let's do this again for B. Our formula for volume is equal to pi r squared h. Our radius, this is the diameter, so our radius is going to be 2.5, we'll have to halve that. So our radius is 2.5 and our height is 12, so our cylinder's just lying down this time. Pi times 2.5 squared times the height, which is 12. Type it in. To one decimal place, 235.6 centimetres cubed. Okay, let's look at question 2. A cylindrical jar is 12 centimetres tall and has a diameter of 8 centimetres. So you can draw that if you like, it's always good to have a diagram. Here's my cylindrical jar. It is 12 centimetres tall and has a diameter, which means the whole way across, diameter is 8 centimetres. So I'm going to have to halve that to 4 centimetres for my radius. Now it says calculate its capacity correct to the nearest mil. Okay, so we're going to need to use this little conversion that I talked about earlier. So first of all, let's use our formula to calculate our volume. Volume is equal to pi r squared h. So our radius is 4, so pi times 4 squared, and our height is 12. Okay, type that in. We get pi times 4 squared times 12 is 603. I'm going to leave a couple of decimal places here for just a minute. Okay, so that's in centimetres cubed, but we want our volume, we want it as a capacity in millilitres. So 1 centimetre cubed, if you think about that, you think of those little wooden centimetre cubes that you used to play with in primary school. So a little centimetre cubed, that actually holds 1 millilitre. So as long as your volume is in centimetres cubed, you can change that straight into millilitres. So that's just simply equal to 603, if I round it off to the nearest mil, 603 milliliters. That's done. Okay, question 3. A telegraph pole is 14 meters high and has a diameter of 32 centimeters. Calculate the volume of the pole to the nearest cubic meter. So, it's got telegraph poles are quite skinny, aren't they? So here's a telegraph pole. It is 14 meters high and has a diameter of 32 centimeters. Now we want the volume in cubic meters. Now I have one of my measurements here in centimeters. I need to make sure my units are the same. My units, they have the same unit here before I do any calculations. So because I want cubic meters, we're going to change our units into meters. So 32 centimeters for the diameter would be, if we would have to divide that by 100 to put it into meters, would be 0.32 meters. Now also, that is the diameter. So I'm going to have to halve that. So I'm going to divide that by 2 to have that as a radius. So that will be a 0.16 meter radius. Okay, so now that we've done all of that, we can find the volume of our pole. Volume is equal to pi r squared h. Okay, our radius we just calculated was 0.16 and our height is 14 meters. Calculating pi times 0.16 squared times by 14 is 1, it says to the nearest cubic meter, so that's just going to be 1 cubic meter. And that's it. Question 4, find the volume of cement in this pipe. So that means the cement to make the pipe. So it's a cement pipe that has a 2.3 outer diameter and a 1.9 inner diameter and is 4.8 meters long. So we want this amount of cement that is making up my pipe. What I want to do is I want to calculate the volume of the outside cylinder and subtract off the little inside cylinder. Now before I do that, I'm going to halve these measurements so that I have the radius. So 1.9 divided by 2, the radius of this one is equal to 0.95 meters. It's the radius. And 2.3 divided by 2 means that the radius of that one is equal to 1.15. Alright, so the volume. So starting with the outside cylinder, pi times by the big radius is 1.15 squared times by the height, which is 4.8. Then I want to subtract my little cylinder. Pi times by the little radius, 0.95 squared, times by the height going back, which is still 4.8. And we type all of that in to get our answer. So pi times 1.15 squared times 4.8 minus pi times 0.95 squared times 4.8 is, it doesn't say where to round it, so let's just do one decimal place. 6.3. My units are meters, so meters cubed would be the amount of cement in that pipe. Okay, now it's your turn to try. So here's 4 questions. Pause the video, give them a go, and then restart to see the answers. Question 1, find the volume, correct your 2 decimal places. Volume is equal to pi r squared h. The radius is 14, and the height is 27. In the calculator, pi times 14 squared times 27 is equal to 16625.31 centimeters cubed. In question 2, we're given the diameter, so I'm going to have to halve that for my radius. So volume is equal to pi r squared h, pi times by 8 squared times by a height, which is 5. Pi times 8 squared times 5. 1005.31 millimeters cubed. Question 2. A cylindrical water tank has a diameter of 4.5 meters. Find the volume of water if it is 1.2 meters deep. Okay, so it's 1.2 meters. We'll just make that the full height of my tank because that's how much water we want. So I need to halve this. So my radius is going to be equal to 2.25 when I halve that. And then into the formula. V is equal to pi r squared h. Pi times by 2.25 squared times by the 1.2 meters of water that I have. Pi times 2.25 squared times 1.5. So that's 19. Doesn't say where to round it. Let's do one decimal place. 19.1 meters cubed. Okay. Question 3. We want to find the capacity. So as soon as it says capacity, we know we want to change this into mils. Find the capacity of a water bottle to the nearest milliliter if the water bottle is 24 centimeters tall and has an 8 centimeter diameter. Or let's just change that to a 4 centimeter radius. So volume is equal to pi r squared h. Pi times by the radius is 4 squared times by the height, which is 24 centimeters. So we get pi times 4 squared times 24. 1206. Okay, but that's in centimeters cubed. But remember that centimeters cubed are the same as milliliters. So it's 1206 milliliters. Okay, that's found to the nearest mil. And last one, we have half of a cylinder here. So all we have to do for that is to put a half in front of our formula. Also, diameter, so our radius is going to be 2 centimeters. So half pi times by radius squared times by the height, which is 9. Half times pi times 2 squared times 9. Find the volume to the nearest cubic centimeter. So to the nearest cubic centimeter, I have to round that up. So what the nearest whole number is what that means. So that'd be 57 centimeters cubed, cubic centimeters. That's it. I hope you got all those right. Keep practicing, and I'll see you next time.